I'll try really put the bar lower than it was before, like this time really. So, like so it's comfortable for new speakers and next time. Let me introduce myself. I'm Tomáš Procházka, and this talk is about how to make a SSH server in Go. Guess question, why would you want to make an SSH server in Go? I will try to give you a few reasons. First, it's a great way to learn how the SSH protocol works. Second, you can build your own SSH server with features you may need. And third, you may use it for testing or debugging purposes if you work with SSH client. Also, just recently, OpenSSH introduced a new feature to block password guessing attacks. It replaces the fail to ban. So you can also use it for custom security or authorization. This is funny project I found on GitHub. It's chat over SSH. So instead of shell, you get a chat prompt. And of course, you can run your own SSH chat server like a alternative to IRC or Slack. So if you want to ask me something during the talk, leave the question here and I'll try to answer it later. Give you a few minutes. SSH, so I'm not sure if you can make it work on phones, but I tried. Okay, or do you want a minute? Time is running, but it's ssh.chat. So
Next project is SSH client for the phone.
it's not mine, but yeah, someone can try. Okay, I work for Dataddo, which is ETL platform, and the reason why we decided to build our own SSH server is following. Many of our customers use SSH for tunneling to grant us an access to their databases and others behind the wall. But for some, the SSH server at their site isn't an option. So the reason, the reasons can be various, like company security policy or having no public IP address and being behind the net. And in this case, it's us who has to provide the SSH server for reverse tunneling. And yeah, as far as we know, the market standard, like competition and stuff, uses like one VPS OpenSSH server, I guess, per customer. And this leaves small and medium businesses out of the game because it comes with an extra cost, cost of EC2. So we want to provide a solution that is cost effective and so accessible to everyone. At the same time, we want complete integration with our platform. The solution would probably be possible with Ops approach, but we more devs than Ops. So now the interesting part. Yeah, to make SSH server in Go, you may use Golang org x crypto SSH package, but it's very low level. Or you can save you some time and use the GitHub comp Glider Labs SSH. There's also Wish from Charm Bracelet project, but it's just a fancy wrapper around this package with bells and whistles. You can notice that the API is very similar to the standard HTTP package. It's also good to realize that when we speak about implementation of SSH server, we're not implementing the SSH protocol itself, but the application, just like we do with HTTP. The SSH protocol is divided into 3 layers. I'll try to explain them in a simple way with some code examples. The transport layer is the first layer of the SSH protocol. It runs on top of TCP and handles the initial key exchange and all following encryption, compression, and data integrity. Interesting fact is that for the encryption is not use TLS, but its own protocol, but it's comparable in terms of security. The closest we can get to the transport layer is setting up some basic SSH server configuration. We can set up server version, like user agent, sort of, but, which is automatically prefixed with the SSH 2.0 as required by the RFC. The most important part is setting up the host key. It's the identity of the server. If not set, the server will generate a new key every time, like the library will generate the new key every time, and this will make the client display the warning message about the host key change. We can also set timeouts. The idle timeout measures the inactivity of the client, and the max timeout is determines how fast the client must type to finish its work. And of course, the address and port the server will listen on. If you plan to run multiple servers with different keys on localhost, you may want to add bottom lines to your SSH config file. Yeah. User authentication layer is the second layer of the SSH protocol. Unsurprisingly, it handles the authentication of the user. The most common methods are password and public key. There is also a less common method called keyboard interactive. It's a challenge response method where the server sends a challenge to the client and the client sends its response back. The GSS API method is standardized API for security services. The most common implementation is Kerberos protocol. And it's worth mentioning that the user authentication is optional. It's denied. Commercial SSH servers may have more methods implemented. And yes, there's more implementations than OpenSSH. For example, Tectia from the original author of the SSH protocol, or Dropbear, which is used for OpenWRT or other embedded systems. The password authentication is done by registered handler. And the handler is a function that takes context and the password. The context is a struct that contains user, session, and connection information. The public key authentication is done in the same way as the password authentication. We just need to register a different handler and compare the public keys. It's advised to use the SSH keys equal function to compare the keys. It's a constant time comparison, so it's safe against timing attacks. The keyboard interactive authentication is a bit more complicated, and I will skip it for now, and we can come back later if the time allows. Connection layer. It's the third layer of the SSH protocol. It handles the multiplexing of the connection by the concept of channels. Another protocol primitives are requests. There are two types of requests, channel request and global requests. I think the best way to explain it is to show you some use case examples, because this is the layer you will be interacting with the most. Pictures finally. So this is the most common use case of the SSH, remote shell. The client opens a new channel of type session and then sends a channel-bound data request for the shell. So in a nutshell, this is what happens when you SSH to some server. What's left out from the good joke, what's left out from the example is pseudo-terminal handling, right? Like window size change, signals, etc. The shell session is handled by the handle function you already saw in the Hello World example. The SSH session implements IO read writer interface for the standard input and standard output. So yeah, if we want client to see like the output, like its input, we need to write back it to the session. That's what the T reader does. The handler is called if the client sends a request to open a shell at the new channel of type session. And all of this is done by the default session handler, which is here, which is registered in the SSH default channel handler map, which like goes here if this is nil. If we want to handle the session differently, we can register our own session handler. Of course, we don't have to implement the pseudo terminal ourselves, but the implementation of terminal would be topic for another talk. This is another common use case of SSH, like not much different from the previous. The client sends a request to execute one command. The client opens a new channel and then sends a request called exec containing the command. Because of how the SSH default session handler, this slide, no, this slide. Because of how it's implemented, we can use it for both, like shell and exec request, like it goes into the same handler. And simply the only difference is that the exec request contains the command to execute. SFTP, it's an inherent part of SSH. It's an extension implemented as subsystem. The concept of subsystems was added in the second version of SSH protocol to allow simple extensibility. The client sends a channel request for subsystem instead of shell, for example, which is the value of desired with the value of desired system, in this case SFTP. The subsystem handlers must be registered to the SSH server, and the subsystem handler does have literally the same signature as the shell session handler. The SFTP server implementation from Dave Cheney takes IO read, write, closer as an first argument. And then the rest of the communication is done in SFTP protocol on top of the channel, which is, as we already know, like the virtual connection on top of the real TCP connection. Thanks to SSH layer, the SFTP is secure, but sadly the pure FTP is faster, so it may never die. Trust me, like in ETL world, like we still see FTP a lot, unfortunately. Okay. Yeah, you can also like request the SFTP directly from the SSH command, but it requires you to know the SFTP protocol, which is binary. But you can also use subsystem for something else, like for example, like a remote toolbox. If you operate on a server without rights to install software, you could use your custom SSH subsystem to run the software remotely, piping the input and output over the SSH connection. But isn't it overkill? Like, isn't it the same as command execution? In this case, sort of. But a subsystem can be more secure because it's isolated from the shell. For example, the Git over SSH is using the exec command, not the subsystem. The Git upload pack is a command that is executed during the Git fetch or Git clone. And it's named upload because it's from the server's perspective. Okay. Local port forwarding. It's horrible, right? Two titles. Local port forwarding is a way to tunnel port from the server to the client. Like the client opens a new channel of type direct TCP IP, and if the server will agree, it will like virtually pull the port. In in our scenario, like Dataddo is the client and requests some database port visible from the customer's SSH server. Okay, this is being done by registering a handler for the direct TCP/IP channel. And yeah, we can use the prepared implementation from the Glider Labs SSH package if the local port forwarding callback is all we need for customization. Like without customization, use OpenSSH, I guess. Okay, so the callback can prevent unauthorized port forwarding, or it can be used for logging, for example. The last thing to mention, the thing to mention is that we need to register the session channel handler explicitly if we want it, because we don't get it. We don't get the default now. Okay. Yeah. In the command below here, you can read the remote DB address and port, and it's because it's about the perspective. Like it's called local port forwarding because it's from the server's perspective, but this command is from the client's perspective. So it's remote. Okay. If we want to forward a Unix socket, we might use special channel, which isn't part of the SSH protocol specification. From the suffix, you can guess that it's Open SSH extension. It's a good practice to use your add suffix if you want to add non-standard features. The same for requests. Okay. And finally, here's the reason why we at Dataddo dived into this rabbit hole. Reverse tunneling. The client first starts listening on the channel of type forwarded TCP/IP, then sends a global request to open a channel of type forwarded sends request to open a channel of type forwarded TCP/IP to the server, and if the server agrees, it opens a channel to the client. When the client doesn't want to share the port anymore, it sends a global request to close the channel. In our case, Dataddo is the server and the customer is the client. So the client like virtually pushes the database port to our server. Also, good takeaway from this picture is that the channels and even requests can be opened in both directions, allowing us to create complex and sometimes messy communication flow. And while the flow was more complicated than any from the previous, the implementation at the server side is not that bad, mostly because the part of the complexity is offloaded to the client. All we need to do is register handlers for the global requests, one for opening the channel and one for closing, or at least until we get with the default implementation, which we wasn't, but yeah. And here's checkpoint for myself, and it didn't work as I expected. I also wanted to show you, yes, please some example. Yeah. Okay. So this is how the like keyboard interactive method look like. So yeah, yes, of course. So you can ask questions like, for example, what's better, like PHP or Go? So Go. And Go fun, so nobody cares. Be back.
This is the challenge authentication method.
Yes, yes, it was hard. Okay. So yeah, the keyboard interactive is set up in the same way as the password and public key authentication. We don't have time, right? Okay,
Yeah.
Okay.
Perfect.
cool. Because this is like a bonus slide. So it's done in the same way, but it didn't fit on the slide, like the server configuration itself. So the handler function takes again the context, and the second argument is a function. The first two function arguments are string, named as a name and instruction, but it's basically what will be displayed to the user. The third argument is a list of questions, and the fourth argument is if the answer should be echoed back to the client. Like for username, it would be true, and for password, false. And you could see that the second and third question was like anonymous. Okay, I just put garbage in. Yeah, and then the function returns the answers in the order of the questions, logically, I guess. The nice trick is that the challenge function can be called like multiple times, even without the questions. And because of its interactivity and flexibility, this method is being exploited by the commercial implementations for custom authentication methods. Ta-da. So this is the end, and I hope you learned something new about the SSH. And it's hard to understand it all like in 20 minutes. I didn't learn it in 20 minutes, of course. So, and I believe that what you saw, like from at least from the examples, you could see that it's not that hard with the proper tools to like implement the SSH server and give it a try.
I have questions.
Okay.
Do you implementing own SSH server for scaling purposes that you can run multiple SSH server per customer on one machine or something?
Yes,
like that?
yes, one server
one
per
thing.
multiple customers.
Do
Like
you implement some extra monitoring, for example, for you that's not normally available, that you can monitor the servers?
yeah, of course, like classic, I would say, like metrics, logs, traces, and of course, like I guess the biggest issue we saw was the user management, because well, you must set up the server, like create the user, because the OpenSSH it's like bounded to
If you
the.
made something of connected to Okta or something that for customers, no.
No, we use our database. Like for the logging, we use our like database, and also like the network management, because like it in the reverse tunneling, it's the client who picks the port of in the destination, which it's not very like safe to leave it on him like completely. So you need to do some like verification, I would say. So like if you use the OpenSSH like IP tables or NF tables, like in some kind of like a firewall rules to limit the user, but it looked very complicated. So I guess like doing if in Go code is much better for me. And also like the security, you cannot fuck up the OpenSSH configuration, because in our like implementation there is nothing, just the tunneling itself, like no shell, no nothing. So should be safe. Of course, it can be like a scaled, like a A/B testing and stuff. So well, gives the
And
like
can you share how many, for example, that servers that you running?
one and two if we are A/B test. Like not many users use it so far.
Okay.
It's
It's in beginning.
yeah, like a testing.